Okay, so I use my screen. Okay, I found out what was wrong with my previous question. I think I typed incorrectly right here. Supposed to be 0.319. Let me see. So what was it? It was this. What was the question? So technology part, right? So this technology corner. No, sorry. Where is that? I can't find it now. All right, here. Okay, so this was I supposed to type 0.319, but I typed 0.39, so that was kind of a little funky. So if you type this, you're supposed to get this one. Okay. So let's go to one of the dice question. Maybe let's do warm up one. So warm up one is I cut and paste to my whiteboard right here. Let's see. So this is a fair dice diagram, right? So if you fold up, it's going to be number generator dice. Okay, so write down the estimate distribution table. Find the standard deviation and expected value. So all you have to do, like, let's create a table, casual table. Like, so its outcome is 1, 2, 3, 4, 5, 6. Now it's supposed to be fair dice, so it's 1 out of 6. So let's write down. Let's go back to the main page. 1 divided by 6. It's 0.66. So I put 0.16.7, right? So 0.167 each, right? So this is the probability of each number, right? So it's going to be like this. Okay. Lock this. Okay. So create this like this. Now, to get the, maybe you can calculate if you want to, but since we just learned how to use the calculator, let's do it. So go to let's go to stats, clean up this one, this two, right? First, let's see. First, clean up this one and this two. Second, this one, comma, this two. Okay, and go to edit, stats edit. So outcome is 1, 2, 3. 1, enter, 2, 3, 4, 5, 6. Okay. Now you go to the second list. 0.167, enter. 0.167, enter. 0.167, enter. 0.167, enter. 0.167, enter. 0.167. So I round up, it might be come up a little bit off, but this is a sort of fair distribution. Okay, now go to second stats and go to I. Okay, so if you hit this one last two, it might be a uniform model, right? Let's see. See, this is uniform model. Okay, so when you go to the equation, you go to stats, calculation, one variable stats test. list 1, list 2, and calculate here. What will happen? Expect value means 3.5, of course, because if you add everything, 1, 2, 3, 4, 5, 6, 21, right? 21 divided by 6, so it's going to be 3.5. You know how I did? So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21. 21 divided by 6 numbers. So expect value is 3.5. Okay? Now, this is what I have. Let's get the standard deviation from here, because we do not have to calculate that much. So standard deviation is 1.7. Okay? So there find the standard deviation, which is this. Standard deviation, which is this. And expected value, which is mean, right? Mean is this. Okay? That's it. So now I will cut and paste here, if I can, to next question. This is next question. What's the difference? Group maybe. Okay, what is the difference? Now you see the number, the same location of the number, it's double. Yeah. Right? Same number is double. So I put this one instead of 1, 2, 3, 4. Let me see. If I cut and paste this one to right here, you see this. It's same location twice as much. Okay? How about this one? Same location, 3 times as much, right? 2 became 6, 6 became 18, 5 became 15. So now you see the scenario. Okay, so that's why I cut and paste. Now all you have to change is right here, double. Instead of 1, 2, 3, 4, 5, 6, I will change to, obviously, 2, 4, 6, 8, 10, 12. And we do this calculation, so luckily we don't have to calculate because it's already here. So I would do is, what I would do is go to second stats, and we don't have to, let's clean up, huh? Let me see. Let's clean up 4 to clean up, and just clean up list 1. Now let's go to edit. List 1 is clear and everything distribution is same. So instead of 1, 2, 3, 4, 5, I would type here 2, 4, 6, 8, 10, 12. And let's see. And the graph is going to be same, right? Histogram is going to be the same, of course. However, let's see the equation. So equation, you go to here, calculation, one variable stats test. Here, everything is same. But what did it change? Instead of 3.5, it became 7.5. Okay, let me put this one here. This is for this. And this is one before. Here, I will cut and paste to next page. This was for one before, which is the dice you usually use. This dice is double. How do you compare this? Double, right? So everything is double. Expect value is double. standard deviation is double, right? So first I wanted you to see. It might be so obvious, but that's how you do it, okay? Of course, if you do the triple, it's going to be 3 times as much, everything. However, this question is slightly different, okay? Oh, warm up 1, and question 1, find the standard deviation except value of mean. Warm up 2 divided by 2. So warm up 2 divided by 2. This value divided by 2 is going to be, go back to this, obviously. This value divided by 3, go back to this. That's I wanted you to see, because you have another question on the following page. What will happen 3 of these dice and adding the sum up, right? If you add the sum up, is this 3 dice you roll up and adding the sum of the 3 dice? Is this same with 3 divided by 3 dice? I'm sorry, 3 times as much dice question, or 2 dice and divide by 2 is as same as you rolling the 2 dice. What's the probability? So that's one thing I want you to find out. Okay, so that's it for today, and this is second tune. This is called see you next week.